Hello YouTube. So what I've got here for you today is a broken TI-84 Plus from eBay. So I bought this in the hope I could fix my own one, but I think that project is a story for another time, because this calculator only has some broken buttons, and maybe we can try to fix these buttons instead of swapping the display around, because on my other calculator the display is broken. So let me just try this calculator out. I can turn it on. It's saying something strange. Okay. I think last time I looked here there was a trace. Yes. So you can see at least most of the display is working. But I tried to change the graph or how it's drawn. So I set the window from minus 10 to 10 to minus 101 to 10. The problem is I think I can't change it anymore. So maybe, no, this isn't working. Oh, it is working. Okay, there you can see it drawing the graph. So that looks good. But the thing I wanted to show you is that when I wanted to change this, I originally wanted to change it to going from minus 100 to plus 10, but the 0 button isn't working. So I can put a 1 here, I can put a 2 here, but not a 0. And also I wanted to go to the next line, and the arrow key for down isn't working either. So I can go to front and to the back of this number, but I can't go down. I can go up, which is bringing me to the beginning of the line, but I can't go down, which should at least bring me to the end of this line. So no, nothing is working on this button. And I think even this button is broken, and perhaps some more. So I think it would be a good idea to investigate first if we can fix these buttons. There might be just a line broken. And if that doesn't work, we can at least take the LCD screen and put it into my other calculator and get that fixed again. But I think we have a pretty good chance to fix these buttons and get this calculator back working again. And then I can deal with my other calculator later. So let me just start by trying to get this calculator apart. So I don't know if we need to get out the backup battery, which is in this compartment here, because it may be possible that when we get the shell off, we get the complete backup battery compartment off with it, so we don't need to care about it. But I think we'll find out. So I just noted a small problem. I can't get my bits down here. So the hole for the screws is too narrow and too long. So the shaft of my screw bits aren't fitting. So they can fit the screws up here, but not the screws down here, where the plastic shell is preventing the bits from getting down there. Also for this one. So I'll just need to find a screwdriver for Torx. And I think it's a T6H I need to get. Okay, then let me just try this again. Now with the TX6 Torx screwdriver, where the shaft is small enough to fit the screw holes. So there are 4 screws, 2 are missing. They are still in their holes. Okay, the last 2 screws are out. And this isn't getting apart. So I'll need to get a little bit creative. I'm just noticing that all my guitar picks are a little bit worn down. But maybe we can get it open. Oh, this one is a little bit too thick, I guess. Ooh. How did I get the other one apart? Sounds a little bit strange. Oh, okay. I needed to pry the other way. So you pry from the top, not from the bottom. Yeah, it's opening. And I hope the clips aren't breaking. So from the top to the bottom. So this way, not this way. Okay, maybe it's held in place by the battery compartment, and I'll need to open this up too. Yeah, I'm using a flathead. I'm using not the correct screwdriver for a Phillips head screw. Do I have one lying around? Okay, that's better. Okay, the battery compartment has a very long screw. So this seems to, yeah, that hold both pieces in place. So when you are opening a TI-84 Plus, you will need to open a backup battery compartment too. So here are the insides of the calculator. And I think you can see something there which I can see too, which shows us a little bit of corrosion, and maybe that's all the problem this calculator has. So I think we'll need to zoom in and investigate. So there's just a little bit of corrosion on this side, and maybe on the other side of the PCB there's more corrosion. But before we can check for that, I'll just need to get the PCB out, and to get the PCB out, I need to get the other two screws out that you can see in the picture. And maybe I'll need to search for more. But I'll look into that later when I got these two screws out. So here's an awful lot of shielding on the PCB and the markings of the battery compartment, but I can't see at the moment that there is any battery leakage, so I'm not sure where the corrosion came from. Maybe it was just something from the other side, so I hope the other side isn't corroded a lot. Okay, it's somehow stuck in here. Let me just get the shielding off. Lift the shielding, okay. There are two more screws under the shielding. Let me just get them out of the way. I know, I'm in the picture the whole time. Okay. Okay, you can pull the shield off completely, and there are more screws. So this calculator is screwed in tight. And it looks like there's a little more damage to the PCB, but I can't see it at the moment. So yeah, there's something which looks like it could just be dirt. So I'm really not sure what I'm looking on. It could be corrosion from the other side or dirt. I'm not sure. This looks a little bit strange. So let's just look on the other side. So let me just lift the PCB out of its shell. And at least I can't see anything special. Wait a moment, it's not really in focus. So I can't see anything special on the PCB. No corrosion on this side. No markings from battery leakage or something else. And also on the keypad, there's nothing to see. It looks really clean, but not what I would expect to make any problems. So under this, okay, somehow stuck together. So under this rubber membrane, there are the keys. So I think I should try to not get them misplaced, or I would have not a lot of fun using this calculator. and the carbon traces, they look very clean. So I don't see a reason for that corrosion. But there are clearly some spots like this one and the one down here that are corroded. And I think we will need to investigate a little bit more and fix them up and hope that the calculator starts working again. So this could be an easy fix and not even be a reason to start a painful cleaning session, because there's not a lot to clean here. I just noticed that on the shielding there's also a little bit of dirt and what looks like starting corrosion, and also here. And this spot lines up with the spot up here, and the spot and another spot here lines up with close to the capacitor. I just noticed that there is a little bit more suspicious going on, but maybe it's just a little bit more of dirt. So let me just show you a microscope view of the corrosion we found. So this is the left bottom edge of the PCB, where there seems to be a placement option for two capacitors that aren't placed. So then we have the shield, which I just need to fold away. We have here the contacts for the battery, the backup battery, but there is nothing to see here. So it's clearly not a problem with a leaking backup battery. So then we have the other position we saw. There is a little bit of corrosion close to this and this via, but I think these three vias up here are just ground. So maybe they are redundant, but this via here is clearly connected to a trace. So if this via has a problem, we might have a problem with one of our signals. And then the other spot was up here, close to a capacitor, but this capacitor, okay, I made this mistake before, but it doesn't look like it had leaked, and it also didn't have strange looking contacts, so I think it's not that capacitor. Close to this mounting hole here, you can see that even the golden finish on the copper contacts is corroded. So there was something here that really corroded some places, but it's really not a lot. I expected more. Yeah, and also I saw on the other side where there's a mounting hole, there's also a little bit of dirt which might look like corrosion. And also you can see that the via up here has a dark tarnish to it. So maybe... but it's really not a lot to look at here. And also you can see the, where is it? So this is the shielding foil. You can see that the foil is a little bit corroded, and there's dirt from the upper spot that is corroded on the plastic sheet. And the plastic sheet, I think that doesn't corrode like metal. It's just plastic. Also close to the capacitor. The plastic foil on the shielding has spots of corrosion where it's clearly not coming from the metal of the shielding, but it's coming from something that happened on the PCB. So let me just start cleaning the spots. So we have our first spot. I have some kind of a contact cleaner, and I have these cotton wipes, so I'll just put a little bit of this contact cleaner carefully on the on the cotton wipe, and just wipe the corrosion away. A nice sound. Yeah, but you can see that the via is corroded too, so we'll need to check if it's still conductive. I think I need something to scrub. Scrubby, scrub, scrub. So this looks a lot better, but still, this via has a black spot in the middle, and also this via down here looks a little bit corroded. But there are two vias, so maybe it's redundant, maybe not. I'll check that later. But first, you need to clean the other spots. So, is there something? Doesn't really look like. Here's the other spot. And still, this via has a little bit of a black marking inside. There's the big spot. Let me just get the foil out of the way. And let me just get fresh contact cleaner. Ooh, that pad is heavily corroded, so something happened there. Okay, let me just investigate this a little bit further. Is there something going under the shield? Okay, maybe. I'll just get the shield off. So there is a little bit of blue tarnish to the glue under the shield and also on the silk screen. So I'll just clean that off because you never know. Doesn't look like it is cleaning off. Also the shield and glue, and that needs to get clean. And I think I just ruined my cotton wipe with glue. So next one to the rescue. And perhaps a little bit of isopropyl alcohol to get the glue off. And there's still the shielding that needs to get cleaned. There's a heavy dirt. So this is one of the battery contacts. I think it's the positive terminal because the other terminal is connected to all this ground plane here. So this would obviously be the ground contact of the battery compartment. So from this one you can see there is a trace running up and further up to the rest of the circuits on the board, and one trace that is going directly to this spot where there is option to place capacitors. So this position here corroded extremely. Okay. So I think the reason for that is that something wet or corrosive got onto the spot, and you have a voltage potential on this pad, on the other pads, and so one of them is getting extremely corroded because there's just power. There's power to corrode it away, and that's the reason why it's gone. But this pad is only a positive connection for a capacitor that would do some decoupling on the battery terminals, and it has nothing to do with the keypad. So this corrosion spot is unlikely to have done any harm to the functionality of our buttons. So we might ignore that, but also have in mind that there might be some vias in this region that are a little bit hidden. I found this one, but there might be more. So if they are corroded, they could be a ground connection for one of our buttons, for example. Okay, on this white silk screen, I think we will not be able to find any corrosion spots because they are being hidden by the silk screen. Then we have this battery terminal that we can need a little bit fresh alcohol. A drop or two. Yeah. Just clean it a little so the battery would have good contact. So the trace I showed you earlier, the positive terminal of the battery compartment, goes to this fuse and then up, away somehow. I think that's a resistor that bridges this over. This is, shouldn't use this dirty little stick. That's just a resistor. I think they placed it here because they had other components in mind and figured out they don't need them. So it's just jumping over here, going through this inductor, which is just for filtering so that no electrical noise from the processor doing its work will get out of the circuit. Yeah, then there are some decoupling capacitors, and the power rail goes further and further somewhere in the circuit overall. But the calculator is powering up, so this would not be our issue. Okay, just knocked the alcohol over, but that's not a problem. I closed it before. So this is one of our really corroded vias, but I think we'll just switch over to the other side and investigate which electrical connections are common to the buttons that were not working before. So we have here on the bottom part of the PCB, let me just get the calculator on the side. We have the on button. We have the 0, the dot, and the minus button. The on button was working. That's this one up here. And you can see something in common with... no, not in common with all of these buttons. That's special for the power button. The outer ring is connected to ground. And the middle contact has its own connection that's going to the other side of the PCB, and then I think it's going directly to the CPU because somehow you need to start it. Or perhaps not to start it, to reset it, whatever, or wake it up from sleep. I don't know. The other buttons, like this one, which is the 0, this one, which is the dot, and this one, which is the minus, or the I think it's the sign invert button. So where when you have a positive number, you can make it to a negative number, or vice versa. These buttons have on the outer contact their own trace going away, or sometimes trace sharing with another button. And they have one connection that is common for all the 3 buttons. And then this button, which I might not have tested. And then this line goes up and up and up and up and up, and then ends on this button. And this button is the down arrow key from the arrow buttons. So this one was not working before too. This shares the outer connection with the other arrow buttons, but they were working before. So the only connection that is common to all these buttons and is not working is this connection, and it's via. So maybe this via is broken, so we will need to investigate on the other side. It's not the via where I said that it looks really dark, but I think it's the via from the other side. So let me just turn the board around again. So it was that via here, close to the hole. So there are 2 holes, and on the inside hole there is a via. Let me turn it around. So we have this hole, which is the hole where the PCB mounted. We have another hole, and we have this via. So I'll put it in place again. So we had this position where we had a little bit of corrosion, and I said, okay, the via looks a little bit dark. And there was not a lot of corrosion here, but I said, okay, maybe it could be that there's a problem. We have the other side where there was a lot of corrosion, and you see the via doesn't look that bad. And we have the spot that was just somewhere in the middle of the battery compartment where there is a corroded via. All these positions seem to at least not yet have a problem. But the spot up here where I said, okay, it's not a lot, it's just a little bit. This is our via that connects our not working buttons to the processor. So this via doesn't seem to have connection. Let me just try to check this. Okay, total chaos has just exploded on my bench. I have soldered a small wire to the connection or the test point on the connection on the 0 button, where the trace leads up and up to this via I want to test. So this one wire is connected to my multimeter, and I'll just now try to get the other side in place. Bear with me for a moment. So this is the via we want to test, and this is the other multimeter probe. So let me just try to get through the lacquer coating of this trace. And at least now the multimeter isn't showing anything. So I'll just use my glass fiber cleaning pencil to get the lacquer coating of the PCB trace. So now I should get a good connection. Clean that off. And the multimeter is showing nothing. Let me just check against my multimeter cable. Okay, there is connection. Perfect. But there is no connection on this trace, so I'll just dig a little bit into this via. Oh, and there is connection. So at least on the top, this via is broken. But somewhere down here, at least somewhere down there was the other connection. Can't find it anymore. But you can see from the digging around in this via. Oh, there's my connection. Yeah, somewhere there. It really looks brown and ugly. And so we just need to fix this via first by rubbing it off. So on the okay, there's not an awful lot of copper left. You can see where I rubbed the coating off. Okay. There's not a trace coming back. Wow, I didn't expect that. Okay, let me just grab a little bit of alcohol to clean this mess up. And you can even see there's the trace coming down. There's a broken connection. There's no copper left. Then there's a small spot of copper. And then there's nothing going to the via. Wow. From what I could see through the silk screen, I didn't expect that there's no copper left. I thought, okay, maybe the hole is the place where it just corroded through. No, there's nothing left. So, yeah, we'll need to place a wire in there to replace the via. So I've got here very small tweezers. And I'm really lucky that there is a hole, so I can put one end through the hole and the other end try to dig a little bit into the via. Okay, there's at least something down there what looks like to be at least remnants of copper. Okay, I think I'll need to clean up the other side. Or not clean it up because it looks very clean. Where is it? There is it. So this side looks very clean. But I'll need to remove the solder mask here too. Just clean it up. So this via looks fine, but we'll need to run a wire through it. So let me just dig a little bit. I hope I will not ruin my tweezers. Okay, can I now run a wire through it? Nope, not at all. So I'll just try to find a very fine drill. So I have here a very, very fine drill. Is it written on here? Yes. Oh, it's upside down. It's a 0.3 millimeter drill. It's the smallest drill I've got here. And I'll just try to hand drill my way through this via. Just by rotating it carefully, trying not to break the drill in the drill hole. I know you can't see very well, but there's nothing I can do about it. Oh, there's a lot of material in the hole. I thought I was halfway through with my tweezers, but no. Okay, I'm through. There's our new hole. I'll put the drill away before I break it. I think these were very expensive. And let me get a little bit of alcohol to clean it away. So we all can get a better view of what just happened. So you can see my finger behind the hole. So now we should be able to get our now very bent, because we tried a lot of times, wire through the via. Okay. Let me just bend it up here. So there it is. Bend it down here. So let me just get a little bit of flux. From this flux pen. And then grab the soldering iron. Ooh, I can't see it very well. Okay. This side seems to be in place. Let me just get the overhanging piece of wire away without hacking through the trace. Okay, that's off. That's in place. So I can just use the still working wire and don't have to count on exactly hitting the trace, because I have a little bit more wiggling room with my wire that's still intact. Just put a little bit of flux on there. And solder it in place. Nice. Okay. A little more cleaning, because the flux could start to corrode away our contacts, and we don't want to have that again. And also maybe the flux could hinder our contact from our buttons. So some of the buttons might be fixed, and on the same instance we have damaged or made unusable the other buttons, because we just put a lot of dirt on them. Oh, our solder connection broke. I think I made that wire a little bit short. Okay, let me just get the camera on the multimeter running again. So we have the multimeter still working. We have the negative connection on the other side. We have the positive connection here, and it looks like that our trace is fixed again. Beautiful. So last time when I fixed the PCB trace, you saw me using a green solder mask replacement that was UV curing, and I had a lot of problems on thicker parts of that coating that it didn't harden through. So I got myself another coating pen. Okay, it's not in focus, but bear with me. It's not really interesting. Which dries itself. So if I don't let it dry out and still can use it, I can coat parts of my... yeah, that's coming out. Parts of my PCB without having to worry about UV light and curing it. And it should be green, but at the moment it looks an awful lot more to be without any color. But it's the first time I use it, so because perhaps the pigments are not in the tip. I don't know. Okay. I'll just ignore that. The overcoat is stinking, so I think it's working. I should try not to coat the buttons, or they won't have any contact anymore. So this looks really beautiful. This looks really good coated. And at least on the tip, I'm getting a little bit of green, so maybe it's coming later. Okay, I think that's it for the repair. I will try the other contacts off camera. So it's the same procedure, so you don't need to hang in all the time. And then I'll come back later when I'm done fixing it or done checking the other vias, and we'll just look if we successfully fixed it. Or if we need to investigate deeper, perhaps. But I think it's a clear win. Just that via, perhaps the other vias too, but I think it will be fine. So a small update on the corrosion situation. That are the remnants of this one capacitor pad. Okay, there's not an awful left of the pad, but also the trace leading to the pad is gone. So nothing to care about here. There was no capacitor placed, so we don't need to replace this pad. But what was more interesting for me is this via down here, hidden in the meshed ground plane. But yeah, that looks okay. It's nice. The other point we found is this via, and you can clearly see that there is a part of the via missing, or the annular ring, and a part is still there. So this via has still connection, but it's prone to fail. So I'll put a new trace in there off camera, but I'll put a new trace in there. And also the situation up here. There's two vias in the some power trace. I don't know what it is, but This one here has clearly no connection around it. And even this via up here is at least close to having no connection, but I think it has no connection. So I need to replace these two vias too. I don't know if it is necessary. I haven't looked on the other side if these vias go in the same track, but why not replacing it when I'm here before I put it back together and start to noticing that something isn't working. I can just replace it. So I'll do that, and then I'll come back later for putting the device back together and testing it. You know what? I really should have opened the backup battery compartment. Yeah, this bastard looks a little corroded, and I think pieces of corrosion material flaking off might have corroded the PCB. Despite the battery compartment itself, the contacts really look super good. They don't have any corrosion. Only inside of the battery compartment, from the battery itself, there were small crystals or something falling off, and they might have contaminated the PCB, and so started the corrosion. So this battery got old and leaky and might have killed the calculator. So then let me just put it all back together again. I think I'll start with top shell and the PCB. Yeah, somehow this way. With the smallest screws. I think the next screws should take the shielding into account. So I'll try to reposition shielding according to the holes. So did I forget something? I hope not. That was a nice sound. So at the moment I don't have a replacement battery for the backup battery compartment. So we can't store any data on this calculator while replacing the batteries. But when the batteries are in, I think it still keeps it memory contents. I'm not sure, but I would think that this will work that way. So let's try to power this thing up. Did you like this repair? Yeah, memory is clear. Okay, which button to press? F1 to F4. Ah, up there. Okay. I think I don't need to press them. Looks great. 0 is coming, dot is coming, this button is coming. I don't have multiple lines. Oh. Down arrow key, up arrow key, side arrow keys. They don't do anything in that menu. Clean. Window. Okay, up, down, left, right. These buttons are working. Can we look on a trace? I think we are missing a formula to trace. Yeah, just we don't have a backup battery, so all memory content is gone and the formula too. So I'll just need to figure out how to type a formula in here. It's a long time ago. I did this the last time. Where's the x? There, okay. X square plus 2. Where was the x? There. -2. Ah, okay. Seems good enough. Plot that thing. Oh, nice. So, display is working. Buttons are working. Okay, up and down buttons don't do anything in this menu, but I've shown that they are working. So, I think this calculator liked that repair, and I hope you liked that too. So please give it a thumbs up and perhaps leave a comment, subscribe, all the nice stuff. And I hope I'll see you in the next video. Bye.